The counting rules useful in probability. Sabi nga, habang nabubuhay may tsansa. Ganito rin ang ideya na nagagamit natin sa pag-aaral. Probability. It is about chance. The study of things that might happen or might not. Probability is almost a part of our lives. Once we get up in the morning, our thoughts fly. The chance of getting a bath, our clothes to wear, and dress up ourselves with matching shoes. The chance of getting on a tricycle after 5 minutes of waiting, flipping the coin or dice, or how big or small the chance to rain on Sunday morning. Or even in voting in the politics. The insurance that suits you, and I think some will relate to this, it's shopping. And these are just so few among billions of occurrences which probability is used. Well, the definition of probability is a mathematical term for likelihood that something will occur. It is the ability to understand and estimate the likelihood of any different combination of outcomes.
And here are the contents for this video presentation. Roll a die. There are 6 possible outcomes that should be equally likely for a balanced die. The probability of n observe an odd number is P of n equals 3 over 6, where 3 is the number of outcomes favorable to n, and 6 is the total number of equally likely outcomes.
This definition of probability will work for any random phenomenon resulting in a finite sample space with equally likely outcomes. Thus, it is important to be able to count the number of possible outcomes for a random selection. The number of outcomes can easily become quite large, and counting them is difficult without a few counting rules. Siguro kung walang counting rules, aabutin ka nito ng forever. Suppose you came from a shopping mall and bought 9 shirts, 4 jeans, and 2 pairs of shoes. If you don't have counting rules, it will take time to count all the number of outfits. So to count all the number of outfits, simply 9 times 4 times 2, which is equal to 72. Therefore, there are 72 outfits. This process is called the fundamental counting principle or product rule. The experiment has n1 ways to perform the first stage, and 2 ways to perform the second stage, and 3 ways to perform the third stage, etc. And there are r such stages. Then, therefore, the total number of outcomes to perform the experiment, n1 times n2 times n3, ellipsis, nk. Another example is 2 dice are tossed, and therefore, there are 6 times 6 equals 36 possible outcomes. However, if you are a kind of skeptical person, you can verify it through a table or a tree diagram. These processes helps you to verify the product rule and enlisting possible outcomes. Last example for product rule. A developer of a new subdivision offers prospective home buyers a choice of Tudor, rustic, colonial, and traditional exterior styling in ranch, 2-story, and split-level floor plans. In how many ways can a buyer order one of these homes? And here's the tree diagram. Using the product rule, 4 times 3 equals 12. Then therefore, there are 12 possible homes. Well, it's up to you if you use tree diagram to verify the product rule's answer. Then that's it for the first counting rule of the product rule.
The next counting principle is the permutation. It is defined as the number of ordered arrangements or permutations of R objects selected from n distinct objects. It is given by n factorial over quantity n minus r factorial. Suppose you are making a 5-letter lock password on your phone. How many possible ways are there in creating a 5-letter password?
So ito na nga. Meron tayong 5 slots. Sa unang slot ay meron 26 choices, sapagkat meron 26 letters in the alphabet. Sa pangalawang slot, meron na lamang 25. Nagamit na kasi yung isa sa unang slot. Sa pangatlo, meron 24. Sa pang-apat, merong 23. At sa pang-lima, merong 22 choices. Using the formula, 26 factorial over quantity 26 minus 5 factorial. Therefore, there are 7,893,600.
Ways to make the password. If taken all at once, NPN equals n factorial. Another example is you want to visit some famous spots in South Korea and you list the 8 famous spots you wanted to go. How many different possible trips are there? Well, using the formula, there are 40,320 possible trips.
Cyclic permutation. Cyclic permutation is the shifting of an entire order of elements one or more steps forward or backward. The first element taking the position of the last, or vice versa, without changing the order of the elements in the sequence, with the formula quantity n minus 1 factorial.
For example, how many different ways can 5 boys and 5 girls form a circle with boys and girls alternate?
So ayun na nga yung keyword. 5 girls, 5 boys, at magpa-form sila ng circle. Boys and girls alternate. So ayun na nga, para mas maintindihan natin yung problem, gumawa tayo ng circle, tatsulok para sa girls, at yung square para sa boys, tapos yung shaded square ay permanently occupied. Sa problem na to, yung permanently occupied, gagawin natin silang boys. Pwede naman tong girls, pero dito sa problem gawin natin boy. So ayan, ito yung ating solution. Let n be the total number of arrangements. So number of ways the boys can be arranged, quantity 5 minus 1 factorial equals 4 factorial. So itong 1, ito yung permanently occupied. Nakadepende naman sa'yo kung lagay mo siya sa boys or sa girls. Pero dito sa problem na to, gawin natin sa boys. So number of ways the girls can be arranged, 5 factorial. So ayan, using the fundamental counting principle, 4 factorial times 5 factorial equals to 2,880. Therefore, there are 2,880 ways or arrangements. So ayan, permutation with identical elements. The number of permutation is reduced when a collection contains identical elements. The number of permutation and objects P of one type, Q of another, S of another, etc. is given by n factorial over quantity n minus r factorial, P factorial, Q factorial, S factorial. An example problem, find the largest number of permutation of the letters in potato. On the word potato, there are 2 O's and there are 2 T's. Therefore, the solution will be 6 factorial over 2 factorial times 2 factorial. Therefore, there are 180 ways. From among 10 employees, 3 are to be selected for travel to 3 out-of-town plants, ABC, with 1 employee traveling to each plant. Because the plants are in different cities, the order of assigning the employees to the plants is an important consideration. The first person selected might, for instance, go to plant A and the second to plant B. In how many ways can the assignments be made? Because the order is important, the number of possible distinct assignments is 720. In other words, there are 10 choices for plant A but only 9 for plant B and 8 for plant C. This gives a total of 10 times 9 times 8 ways of assigning employees to the plant. The third counting principle is the combination. It is the number of distinct subsets or combinations or size R that can be selected from n distinct objects. It is given by n factorial over r factorial quantity n minus r factorial. Ang pinagkaiba ng permutation sa combination, ang permutation the order does matters, while sa combination the order doesn't matter. Halimbawa, meron kang harina at tubig ng paghahaluin. Mauna man ang harina, sumunod ang tubig o tubig sa harina, hindi ito mahalaga sapagkat iisa lang ang kalalabasan nito. Example, how many different combinations do you get if you have 4 books, Science, Mathematics, TLE, and MAPE, and choose 3? So the answer is 4 combinations. 4 combinations lang kasi, halimbawa, Science, TLE, at Math. saka Science, Math, and TLE. Wala itong pinagkaiba. Ito ay may tuturing na isang kombinasyon lamang. Another example, 4 cards are selected from a 52 card deck. The number of ways of selecting 4 cards is 270,725 ways. Next example, in how many ways can a committee of 3 consisting of 4 civil engineers and 2 electrical engineers can be formed from 5 civil engineers and 3 electrical engineers? Number of ways of selecting a civil engineer is 5. The number of ways of selecting an electrical engineer is 3. Therefore, using the fundamental counting principle, 5 times 3 equals 15. Therefore, there are 15 ways. And those are the counting rules used